In this video, we're going to discuss the basics of capital budgeting. So we're going to look at a series of techniques and try to determine the economic value that a project will bring to the company. So what is capital budgeting? Essentially, it's the analysis of big projects. We want to look at buying a piece of equipment, building a new plant, if you will. We're going to look at the very long-term decisions. The short-term analysis of assets, any assets that have a life less than 1 year, are not included here. So obviously this is looking at the long-term life of the company. These are very important decisions for the company, as they may ultimately determine the company's success or failure. So what are the steps? Well, we need to estimate some cash flows. We'll talk a little bit about that in some future videos. For right now, we're going to assume that we've done this step. We need to assess the riskiness of cash flows. And this comes later videos. We'll incorporate exactly how we analyze the riskiness of those cash flows and how we utilize that in our decision making. Along with that, we need to understand what will be the ultimate cost of capital to the company, right? We have some videos we've talked about in the past where we've calculated the weighted average cost of capital. We may need to adjust that for the riskiness of projects. And then we go and do the analysis. The basic analysis is to find the net present value and or the internal rate of return. And of course, we will accept projects if their net present value is greater than 0, or if their internal rate of return is greater than the weighted average cost of capital. In addition, in this video, we're also going to review some additional techniques that might provide some more information about the projects that we could use in making our decisions. So first, let's talk about the different types of projects. Mutually exclusive projects are projects where if you accept one project, you reject other projects. And all projects kind of start this way, right? If you're going to buy a pizza oven for a pizza shop, you don't just look at one oven. You're going to explore maybe 4 or 5. You want to find the oven that's going to provide the greatest amount of benefits for the cost. And where that implies a ranking. So mutually exclusive projects will rank projects from best to worst. We accept the best. That means all the rest have been eliminated from consideration. Now, independent projects is what we ultimately end up with in our capital budget. Excuse me. So all the projects that we've analyzed and have ranked them and have identified the best of all of those projects, those are independent projects. Now, which of those projects do we do? Well, we're going to do all of those projects to fulfill our capital budgeting strategy, right? All projects greater than net present value of 0 will be accepted, or internal rate of return greater than the weighted average cost of capital. But the idea of independent projects is each project is going to be identified and then judged independently on its own merits. There are some other terminology that we need to discuss. Types of cash flows. There's something referred to as a normal cash flow stream. This is where we have a cost, a negative cash flow, followed by a series of positive cash flows. There's only one change of signs in the cash flows. Non-normal would have more than one change. Now, when we use the word non-normal here, I don't want us to think about this as being something that never happens. It happens all the time. especially in manufacturing concerns, where one project, because of its size, when it is replaced or when it is rebuilt, for instance, that year of the project's life, it may actually have a negative cash flow. So normal is the most common, of course, but on the other hand, these non-normal things do happen, and we have to be aware that when they do happen, how do we deal with that? So let's start with our first technique, net present value. This is the sum of the present values of all the cash flows in the outflows of a project. So net present value, as you see here, is a sum of all of the cash flows, and it's the present value. Now in Excel, how do we write this formula? Well, first we have to remember that cash flow zero, right? The cash flow in the beginning is always going to be negative. So you take the net present value, and then into parentheses, the first variable is the rate. That's your discount rate for this project. And then you're going to highlight all of the cash flows, the future cash flows, from 1 to n. All right, so again, this formula, this is just a little quirk in Excel. This formula does not start with the first cash flow. It starts cash flow 1. Then we add to it cash flow 0, which by definition, 99.9% of the time is always going to be a negative number. So here we have a couple of projects, L and S. It's a 3-year project. We have the cash flows identified. We've also created a column here for the change in cash flows. We'll use that a little bit later. But as you then identify what? The cash flow times 0 is a negative number, followed by its positive cash flows. Now, what does our worksheet look like? Or if you created a worksheet, what would you create? Well, you need a couple of cells for the discount rate and a reinvestment rate. We'll talk about that a little bit later. And you also need a column for cash flows. And then you need a formula. So here are our formulas. I placed them down here so you can see them written out. Now, payback and discounted payback, it's a little bit more difficult to do those formulas. We'll talk about how we do that in a second. But here's net present value. You take the discount rate, right, equals net present value. Here's the discount rate. Then you put in the cash flows, right, highlight these numbers, and then you add the investment. And likewise, here are the other formulas that we might use in our other techniques. So let's see what happens with net present value. So for project L, the net present value is 18.78. Now what does that mean? Well, it's greater than 0. That means that it is an acceptable project. We would want to do this project. What about S? S, 19.98. So again, it is greater than 0, so we would want to do this project. If these two projects were exactly, if the two projects were independent, we would do them both. But what if they were not? What if they were mutually exclusive? We have to pick the best. Net present value, as we'll see in a second, measures the change in wealth to the company. Management's financial goal is to maximize wealth. So we would want to do project S since it is going to maximize wealth the most. Again, if net present value, it equals the present value of inflows minus the cost. This measures the net gain in wealth. That's why greater than 0 means you're increasing wealth. And as I mentioned, in this example, we would accept S is the best of the two projects. And of course, if they're independent, we would accept both projects. So let's go to another technique, the internal rate of return. The The internal rate of return is very similar to yield to maturity. We'll bet you this in a second. It essentially measures the rate of return earned on this investment if you buy it and all the cash flows occur. So our Excel formula, it equals IRR. Now in this one, notice you put in cash flow 0. So it's all the cash flows. You highlight all the cash flows in the problem. And then there's a comma, obviously. And then you just put in a guess. Whatever you want to guess. 1%, 2%, 3%. It doesn't matter. You just plug in a guess. And it will calculate then the internal rate of return. Again, if the internal rate of return, if it's greater than weighted average cost of capital, essentially what that's telling us is the project's return exceeds its costs. So there was something left over. That obviously goes, and when things are left over, that goes to the shareholders. So if they're independent, you would accept them both projects. Oops, I'm sorry. Here's the projects. We'll go here. The internal rate of return for L is 18.3%, and the internal rate of return for S is 23.5%. So again, they're both greater than 10%, so both are acceptable if they are independent. However, if they are mutually exclusive, we need to pick the best of the two. And of course, in this case, S exceeds the internal rate of return of L, so it is the most acceptable of the two projects. And as I mentioned, this is very similar to the yield to maturity for a bond, right? Essentially, it's just the rate of return if you buy the project today and all of these future cash flows actually occur. Well, that's it for this video. Look forward to talking to you in the next one. Bye-bye.